Thank you for joining us for this afternoon session, building Windows apps with the ArcGIS Runtime SDK for .NET. My name is Mike Branscombe. I'm the lead product engineer for the ArcGIS Runtime SDK for .NET. I'm joined by Morten Nielsen, who's the developer lead for the Runtime SDK for .NET. So the first thing I wanted to say is we really think about the SDK as the godfather of all the runtime SDKs. So much so that we had so much content we had to split it into two parts. So this is very much part one, looking at building Windows apps, and then right after this session in this room, so at 2:30 till 3:30, there's a session on building Xamarin apps. So this slide shows an overview of the ArcGIS Runtime Sessions at the Developer Summit this year. And the way we've organized the sessions really mirrors the way that we actually build the ArcGIS Runtime. So the common core code base, the common architecture, common design of the API allows us to host a series of cross-runtime sessions that cover the functionality that's common to all of the ArcGIS Runtime SDKs. And then we have a series of sessions just like this one that cover the SDK-specific content. So that's all about, this session specifically is going to be all about .NET and building for Windows and ultimately cross-platform as well. There's a list of sessions on there that cut across all of the ArcGIS Runtime SDKs. That list is kind of a reference guide for you. The slides will be available afterwards to download online, and the recording will be available as well. That's a list of sessions that we recommend you go and take a look at to give you an overview of all of the functionality in the ArcGIS Runtime SDKs. One particular highlight on there is the API and architecture session. That's highly recommended. And then there's a whole series of sessions right from portals to working with imagery. There's also some great sessions that are running in the demo theaters this week, and there's also some great user presentations as well that I'd encourage you to go and see. So when we started planning the session this year, we looked at your feedback from last year, and one of the common themes in the feedback is you didn't just want to see the same session again each year. Typically this is an introductory session to the Runtime SDK for .NET. So what we thought is we'll just give you a link to last year's recording. There it is, the esriurl.com/ds2017net. You can find the recording for last year there. But it was last year's Dev Summit was a major Dev Summit for us because it was the first Dev Summit since we released the ArcGIS Runtime Series 100. And that was the culmination of a number of years of effort in re-architecting and redesigning the API to provide that common core code base and the common API design and patterns that I was talking about earlier. So it was a major milestone for the ArcGIS Runtime. That meant that in that session, we covered some of the overview and the history of how we got to the point we are now with the SDK. We took a look at the architecture, and we will take a look at that again today because it explains a lot about how we build the SDK and the APIs that are included with the SDK, and it gives you great background into how you can build your apps on top of the SDK. We also took a look at some of the new technologies that we started supporting with the version 100 of the ArcGIS Runtime SDK, so UWP and Xamarin. We took a look at explaining what those technologies are. We also had the Getting Started section and discussed installation and integration with Visual Studio. So we did make some changes in the last couple of years to the way that you actually get hold of the SDK and the way you install it. We no longer provide an MSI installer. We switched to using a Visual Studio extension, so a V6 that integrates with Visual Studio, provides you with project templates as you've been used to in the past, but it also creates a local source containing NuGet packages. So the API is only available as NuGet packages now. They're available on NuGet.org, and you can search for those and install those into your projects. Or if you install the Visual Studio extension, it will lay them down on disk in the local NuGet source. We also took a look at building a simple app, so that was an introduction to the API, and then we talked about migrating from the previous major release, and there's a guide topic on that in the documentation if you're still working with 10.2x or 10.2.7 today. And then we also took a look at the road ahead for 2017. Okay, so what are we going to cover in this session today then? We'll take a look at what we did in 2017 and into early 2018, the new features and functionality that we were able to deliver last year. Again, we'll recap the architecture of the SDK. We'll take a look at the toolkit. So this is one of the most hotly requested features over the last couple of years, is bringing back and enhancing the toolkit components that are available to you with the SDK. So we've spent a lot of time working on that recently, and we'll talk about the work that we're doing there. Then we'll take a look at some tips and tricks. We've got a variety of demos in there that take a look at some of the more hidden features in the API that we thought we might not have sampled enough or documented enough, so we wanted to promote those today. It's almost an un-API session, actually, I guess.
Un-API, I like that.
And then we'll take a look at cross-platform development, and again, then the road ahead for 2018. Okay, so what did we do last year? Well, actually, this slide is the slide that I presented last year when I was talking about the road ahead. And one of the reasons I wanted to talk about this is all of these features that we said we would do in 2017, we actually delivered about 95%, plus a few more features. And I think that made me really proud of what the team and the runtime group as a whole has been able to achieve over the last year, because I think that's the first time I've ever been on stage and presented a road ahead slide one year, and then the following year was able to say we did pretty much everything that we said we were going to do. So this was a really pleasing slide to see. The one thing on there that we didn't quite get to spend as much time on as we'd hoped was the toolkit, but we will be talking about that today and the work we're doing there. So what did we do in 2017? Well, we delivered all of those features and functionality that were on that slide. It's fair to say that a number of those features were just providing equivalency with the previous generation, the 10.2x SDK, so filling out some of the features that weren't quite available in the first release of the Series 100 API. But at the same time, there were a number of new features on there that we've never had before. So rasters on Android and iOS, being able to take an entire map offline and supporting multiple different patterns when you're taking a map offline and synchronizing that. There's the camera controllers in 3D are another new feature that we've never had before. The support for service area and closest facility locally on the device against local transportation networks and ArcGIS locators. Some new support for data types in there, so vector and raster data from GeoPackage. All of those features we never had before in the 10.2x API, and we were able to deliver those alongside filling out that equivalency. So really the version 100.2 and the recent patch 100.2.1 puts the ArcGIS Runtime SDK for .NET and the whole of the ArcGIS Runtime in a great position. There's also a note on there about a patch that we released in February for the ArcGIS Runtime local server. So for anyone using that, if you're installed on Windows 7 Service Pack 1 or 2008 R2, the Windows update that addresses the Spectre Meltdown patch caused an issue for the ArcGIS Runtime local server, so we released a patch for that across actually the retired WPF SDK 10.2.5, because we know there's a few of you still using that, but then also the .NET SDK 10.2.7, and then actually all of the local servers through the 100 series. So there's a patch available to download if you're running on Windows 7. Okay, so now I'd like to hand over to Morten, who's going to give you a recap of the architecture of the ArcGIS Runtime SDK for .NET.
Thanks, Mike. We did actually present this slide last year if you were here, but I still think it's really worth talking a little bit about how we built this and what the .NET Runtime really is, and it will lay some of the foundation for what we're also going to talk about later. So when we talk about the .NET Runtime for the Runtime SDK, it actually means quite a lot of platforms. You might have seen some of the general platforms for, or these slides similar for just the runtime in general for all platforms, but we have one here specific for .NET. And what we really do is we of course have the OS, and they're all quite different. We have Windows, and the Windows runtime is the newer universal thing. Of course, I have iOS and Android. And on top of that, we build this big C++ core. And this is the core that's running on all the different runtimes you see everywhere. It's all built in C++. It's cross-platform. It can use OpenGL and DirectX for rendering, depending on where it's running. And well, I've cut it off, but there's also the one that runs on Mac and Linux and stuff. But for the runtime, at this point, we don't support that. And then what we do is make a little interop layer to call from .NET into C++. And so really what you see in the .NET SDK is really just a set of I was almost going to say NT class, it just calls into native code. And that guarantees you that the code that is running on one platform is going to work and behave the same way as on another platform, because that orange color at the bottom there is basically the same code. And then, of course, .NET runs quite different on each one. On iOS and Android, we use Xamarin, and that's based on the mono .NET runtime. UWP uses the new .NET Core, and WPF uses the more classic .NET framework. So there's actually very different frameworks they execute on, but the same code that runs everywhere. And that actually gives you also similar power to just run this .NET code on all these different frameworks. But there are some differences in these platforms, and it especially becomes when we talk about the UI layer. In WPF and UWP, we typically use XAML. In iOS, we use what they use, the UI view, I believe, and Android uses the view classes. So these are all actually native platform classes that takes the whole runtime and then renders it the way that you want to render it. For instance, in WPF, you want to use a XAML control, and it uses that, and it instantiates all the DirectX stuff you need. On iOS and Android, it uses those native classes to actually create OpenGL views and render there. So it runs very native and exactly the way it's supposed to run on those platforms. So there's really, in the end, when this whole app is compiled, there's, for instance, no difference between the iOS Xamarin app and the iOS app in the way everything runs and executes. In the end, it really generates the same code. It's just the language you use to create that app that is different. So again, all the down there is where that's pretty much where all the code is, but you'll see this common SDK on top. That is the same code you have to write on all 4 platforms. I'm going to have a session later today to really go into the whole Xamarin piece to it. I'm just going to kind of show a little bit of demos of it because it is generally with .NET. But this piece on top is the piece that is not cross-platform. So you can't do WPF XAML on iOS, for instance. So that's where the API will start differing, but everything else, your business logic, the way you deal with maps and renderers and getting data offline, all that code is completely reusable on all these platforms. But we also have this thing called Xamarin Forms, and that actually abstracts away the differences in the UI. So you can use XAML on iOS and Android by using the Xamarin Forms. So we also provide it's essentially a wrapper around the native UI controls that gives you one UI markup that can render on 3 of the platforms. At this point, there's no WPF support because Xamarin Forms does not support WPF. They do have a branch for it. So these are the 3 you can get. So you can actually hit quite a lot of breadth just with a single code base. Yeah. It's a more simplified view. You can kind of look at it like this. So it's just a little bit of difference in the UI layer, but everything else is the same. So anyway, just let's get into it. Mike said we didn't really finish the toolkit. Our plan was actually to have a new beta with a bunch of new Xamarin stuff out last week, and we hit a couple of showstoppers in iOS. So we're working hard on getting that out and trying to get that wrapped up this quarter or next quarter, we'll see, and actually get a proper release out. But I want to show you what's there because you can use the toolkit. All of this is open source. So you can go and grab the source, or we actually have NuGet packages this way to get it. So I'll actually go and show you that. So the repo is up on GitHub. So you can just go github.com/Esri and just search for toolkit right there, and you'll find this website. Apparently I fixed the Android sample last. But you'll actually see there's the source code. You can just hit and click download. There's also some information about I'm in the wrong repo. I am so sorry. Let me just jump over here. My bad. This is the repo you want to be in. Here I fixed Xamarin Forms. But you can actually see in the open here, we're going to actually, up until now, we actually done most of the work with internal issues, but we are actually in the process of moving. Or did you already move all the issues over? Not yet. We're going to move all our issues in here and make it completely in public, and if you want, you're welcome to help out as well. But the source code is here, and you can grab it, and we actually support all those platforms you saw up there. And we're kind of filling in as we go per platform, and UI is actually a lot harder to do per platform, so it takes a little longer than all this more the base business logic, which is completely reusable. So we kind of have a little grid here as well where we're at right now. We're going to fill this in more to so we're going to see what the plan is for each and where they're, like links to the pull requests or the branches. That's going to be there soon, but you can UWP and WPF are actually quite far ahead because for the most part we can port it over from the older 10.2 and just tweak it for the new APIs. But we are hard at work trying to get Xamarin filled in as well. And once you see Xamarin Android and Xamarin iOS be available, we almost get Xamarin Forms for free. So generally that one lights up right away once we are on this platform. So these are the controls there's there. You're going to see very soon if you click on issues up here, you should be able to very soon get a little feel for where we're at and what's coming. And you're welcome to suggest things too, not just report bugs, but suggest features as well. Let me switch to here's actually a little sample app. And that's another thing we want to work on, the sample app we want to improve. They're not great. Right now they're more of a test app, I would almost say. But here I have, for instance, there's a visualization of what the compass control can do. So it's a little hard to see up here, but there's a little arrow up here. So when I rotate the map, from a TouchWorks, it'll actually rotate with it. If I tap it, it resets. And even the default behavior is actually that when it resets, tap again, it actually auto-hides. So you only see it when you're not having north up. Especially in 2D, this is a little more useful. Turn this on. So you see it disappears up there. If I rotate the view, it pops back up. When I can tap it, it goes back. First, one of the controls. We have this thing called a feature data field. And it's basically, almost think of a single component in view to build a form. So you want to be able to have a set of attributes the user wants to edit. And some of these fields might have range values. They might have coded value domains and so on. And it's actually quite tricky to figure out how to write these. So the feature data field, you actually just bind it to a feature in a specific field, and it will render the right thing and render a checkbox or a combo box or a text field with validation, everything for you. And so in this case, what you're actually seeing here is, I can't believe this, there might be 4, but I have at least 3 fields here, edited fields. And it automatically creates this combo box. I think the first one, the title, is actually a feature data field that's set to read only. And this can be quite useful for these coded value domains because you might just get the value 4, but it might mean tree, for instance. So it'll automatically figure that out for you. So I can go ahead and change these and hit apply. I can remember which one I clicked. Let's click this green one over here. Let's change the color. It should change to red. There we go. So that's a control you actually use to build up a whole form. And you can actually take that even further and take the built-in data grid in WPF and just create custom columns. And then plop this field into each of them. And you actually get a whole data grid. So you don't really necessarily need a whole data grid control because you have the components to build a data grid control that's already out of the box in WPF. And then so it's essentially the same thing. We have a legend control. And we actually split it up. We kind of split up in components. There's a legend for a layer and all its subcontents, but there's also one that shows for the entire map. And so the one that shows for the entire map, of course, uses the one per layer. And that gives you a little more flexibility how you want to set up your layout. And it can also be based on zoom scale. I believe this one is not using that. We have some measure toolbars that helps you just quickly make a measure experience. And all this is templateable. If you don't like the look of it, you can change what it looks like, but you get support for doing measurements, area, and so on. And this is actually using the underlying sketch editor, so you can take that. If you don't like the UI or the layout of the way it works, like there's a UI, you can usually retemplate, but the source code is there, so change it all you want. Or if you think that what you changed is really useful, make a pull request or make a suggestion in the GitHub repo, and I'd be more than happy to take a look at that. We have a little scale line. This is quite useful for calculating current scale. One of them is a little more expensive, so it only updates once in a while, while the other one updates as you zoom. But the one below is actually a lot more accurate because it changes with my panning. So it does a more advanced calculation. So not that you can't update the other one on each zoom, but it's more of a recommendation to try and reduce too much work. What else do we have? Table of content. Might have been my number 1 requested feature. I have this pop-up because it's just to test that things fail to load if there are security issues. And this, by the way, also a control in at least in WPF right now. This whole layout view is a control as well that allows you to really simple create sign-ins. So every time you encounter a service that's been secured, you can basically set it to, like, if you ever see a service that's secured, pop up this dialog. And it supports also remembering credentials in Windows' credential locker and all those things if you want to store them. I don't actually remember the password for this one, but you see this actually tests that it now turns red, and you can, for instance, right-click it and try again. So I can say reload, and it will pop up again. So there's various integration for that. And this one actually can be changed to also include the legend control. So if I say show legend, now I should see, there's all the legends in here. So you get more of the kind of experience that you will see in Pro and ArcMap. And most of these controls are in UWP. Subset of those are currently in Xamarin. We're working hard on trying to get them all in so we get more parity. Some controls we actually thought about, well, these, for instance, the TOC control we feel like is mostly a desktop-centric thing you don't want to be using on your phone. So currently that is not planned for Xamarin. But of course, if you guys are of different opinion, let us know, and we can take a look at it. As I said, you can make pull requests. I believe there is a pull request in here. And we actually have this little checkbox here. It says, AppWare build succeeded. And it's actually quite cool. When you make a pull request, it automatically triggers a build and checks that you don't break the build. So if I scroll down here and I say show all checks, I can actually say build succeeded. And that saves us time, because if you know that your pull request broke the build, we'll just say, can you fix that first? And then we'll take a look at it. But you also get instant feedback. It takes about 10 minutes for it when you make pull requests. It starts kicking and saying pending, and then it's done. You can actually go and see the whole build output. You can even click artifacts right here and download those NuGet packets that was just generated with your pull request, and you can actually use that for testing. Even better, this is called AppWare we're using. Actually, automatically, every time you merge to master, it generates a set of NuGet packets automatically and creates its own NuGet feed, and you can actually reference that NuGet feed. So if you want the very latest, greatest that's in the master branch, and you don't want to wait for a major release, you can just point to that NuGet repo, and you can actually get whatever is there right now. So as I said, we had a few iOS issues, but if you don't care about that right now, just go and grab the latest one and you get all these things right now. So it's in essence already available. It's just not up on the NuGet.org server that you normally use. It will be on the specific AppWare. And then it's the link to that NuGet service on the README on the front page. I believe that was NuGet. Any questions on NuGet? Cool. Oh, sorry, NuGet. I meant Toolkit. Not that either. Anyone here not used NuGet ever? Couple of hands. Oh. So it's essentially the new way to reference package in general, like DLLs and stuff. Instead of doing assembly reference, it's going to have a lot more power in it. And you don't actually have to install our product. You can just reference NuGet package from online. And it'll automatically store them. So yes, I think that was Toolkit. So just a quick recap. Q1 has Mike put on our slide, so I guess we got to get this finished up. Yeah, Compass, Legend, Scale Line, Time Slider will be there cross-platform. I believe that pull request is actually the Time Slider pull request for Xamarin Forms, so that one is about to go in. Yeah. Tips and tricks?
Okay, great. Thanks, Morten. So next we thought we'd cover some tips and tricks. Like I said at the start, some of the more features in the API that we thought weren't promoted enough in our doc and samples and you might have missed. So we pulled out some of those, and then we'll just run through those in the next section. So we'll take a look at some of the new samples. On the slide that I showed earlier about all of the new features and functionality that we delivered in 2017, one of the things that didn't cover at all was all of the work that our team's doing on samples and documentation, example apps, dev labs. All of those resources that help you be productive with your development. I actually didn't cover any of those on that slide. And the team's been really busy. We actually reorganized our team a bit halfway through last year to enable us to have much stronger focus on documentation and samples. And that's really paid off. We've added lots and lots of new samples to the samples repo that we host in GitHub. So the sample source code is out there. But also we integrate that back within our documentation, and we'll take a quick look at that. And some of those new samples. And then Morten will take a look at animating graphics and features, and then we'll take a look at some of the renderer types that you might not be familiar with, and at least how you do those in the API. a look at labeling and some of the new labeling features, and then running Python scripts within our .NET API as well. Okay, so we'll start off with the new samples. So I don't know how closely any of you have been watching the samples GitHub repo, but that's where we put all of our sample source code. And the intention of those samples is to be very discrete, focused samples that showcase how to do a particular piece of functionality within the API. They're not designed to be larger applications that pull together entire workflows. This is the WPF sample viewer. So I've downloaded the repo of the samples, and I've compiled the WPF sample viewer. And on the features tab here, actually for this demo, I've added a lot of the new samples that we've done. In fact, when I was looking back at all the commit history, these are just, I think in the last month or so, we've added about 20 new samples. And that's quite significant because when we add a new sample, we add that on WPF, UWP, Android, iOS, and then Xamarin Forms on Android, iOS, and UWP. So when Morten was talking about that architecture, we're adding samples for each of those platforms. So let's take a look at this one. This is one of the new exploratory visual analysis tools. We're looking here at scene view control on the right-hand side, and if I click on the view, so to define two locations, you can see that it's running that viewshed operation. It gives me the visible section and then the it's line of sight. It's giving me the visible section and the non-visible section. The next new sample that I'd like to take a look at is another one of these visual and exploratory analysis tools. Again, this is line of sight, but it's attached to a moving graphic in this case, and you can see as that graphic goes around the building, you can see the line of sight is changing between non-visible and visible. And we also get events. So up here you can see text to tell us that the target is obstructed at the moment, and then as it comes back around the building, we'll eventually see that will become visible again. Moving on, some more of the 3D. So this is, the first two were line of sight. This one's the viewshed operation. So if it's performing a real-time viewshed. And actually this is a really good example because it's the network connection's a little bit slow here, so it's streaming in this data. And you could see there that the viewshed was being recalculated based on the data that was actually in the display. So this is visual analysis based on effectively what I can see right now, the data that's available to me in the view. I really like this one. It's more like a computer game, actually. If I tap over here, the tank's going to drive over there, and we can see what the tank can see. But actually, I'm driving through all these buildings in this city, so destroying the locality here. So some excellent new 3D examples here. We've also, some of the features that we added to the geometry engine, support for transformations. We can see here, this is just within the API for this location, it's returning a list of all the suitable transformations, and we can see that as I click on these, the red cross actually moves around that blue square, so we can see we can actually compare the relative accuracy of these transformations over that location, which is quite interesting. And then the grayed out transformations there are not available to me in the data set that I've got currently. There's a number of raster renderer types that we added as well. So the ability to specify blend renderer, stretch renderer, hill shade. Actually, let's take a look at the hill shade. And that's applying that function on that raster locally that I've downloaded here. GeoPackage support here. We can see support for feature layers within a GeoPackage, just a simple point data set there, and also raster data coming out of a GeoPackage there. So direct read of GeoPackages. Shapefile support came back in 100.2, so that's one of the equivalency issues with 10.2x. GeoPackage was an example of one of the new features that we've added as well. And then if I scroll right down to the bottom of the list, we'll touch on the local server component that's available with the ArcGIS Runtime SDK. Shortly, but some new samples here for working with the local server. So actually a geoprocessing example here with the really angry progress bar telling us that the service is just starting up. So this is actually just starting up a small local geoprocessing service on my device, and then it lets me choose the distance between the contours. And if I request those contours, it's now taking that raster data set that we can see, and then it's converting the elevation to contours, and then we'll return that and display that within the view. And then there's some other examples there as well about adding data dynamically into local services. So the reason I wanted to show that is, one, just to remind you that there's lots of samples out there, and we're adding new samples continually. Not only do they appear in the GitHub repo, they also get pulled into our developer site as well. So on the ArcGIS developers site, we can see that there's a tab for samples. So up in the top left there is the GitHub repo containing the samples. In the middle is a view of our developers site for the Runtime SDK for .NET. On the samples tab, all that code is basically pulled through and hosted within the site there. And then also our API reference as well. We've got an internal process that captures identifies all the types that we use within the samples, and then whether they're relevant to demonstrate those particular features in the API, and that sample code gets pulled into our API reference. So there's 3 different places that you'll see that sample code appearing. Okay, Morten,
cool.
Over to you.
Thank you. A sample I really wanted to show, because it actually has been asked quite a lot, or people are doing similar things, is moving stuff around the screen more in a smoothly animated way. And a typical scenario is you get an update of something and you want to actually do it more smoothly movement of that instead of just jump things over. And I actually want to just give through a couple of tricks to how to do that. And actually, let's show some code to do that. So just to see what I'm talking about, I have a point here and I can just click somewhere else and it will smoothly go over there. And we can try and improve this a little bit, but I want to show you how this actually works. Because I think it can be quite useful for doing these kind of animations. It gives it a bit of improved experience. So the trick is, I'll go back to my slide. It's really basic. You just move the graphic, right? You just keep updating its X and Y. So for each frame, you go like multiple times in a tight loop. You just keep moving a little bit closer to where you get. So it's not like rocket science. It's simple trigonometry, like what's the delta divided in how many frames. And typically, you run at 60 frames a second, which means you have about 16 milliseconds between each update to actually move it. That number varies a little bit. If the system gets taxed, it might slow down. If you switch to remote desktop, it typically goes to 30 frames per second. But there's ways to actually tie into that, and I'm going to show that. So you might not actually get a frame exactly every 16 milliseconds. It might be sometimes 12 seconds, sometimes 20. Yes? Is this better? Good, thank you. But for instance, WPF and UWP has one way to do that. Is there's actually a frame event you can hook into. And this event is called, let me find it, in my code, it's called Composition Target Rendering. Very, very intuitive name. But it's actually every time the composition triggers a new frame, this event can happen. This is a big static event. Once you start listening for this, it starts constantly running the render thread. So if there's nothing that changes on your screen, typically WPF and Universal Apps, they stop doing anything. They just kind of go to sleep. They're really nice to their battery. But if you listen to this event, it's like, oh, someone cares about the frame rate, so I better keep pumping. So just be aware of you shouldn't be listening for this longer than you really need to. So once you're done moving stuff around, unhook from it, and I'll show that. So basically, this little method basically just takes where I tapped. So I mean, where I come from, some kind of stream or something. And I just basically grab the start position and the end position. And then I create this event handler. I'm just creating this an anonymous delegate. It doesn't have to be, but I just have it all concise in here. And the first thing I actually do is, for some reason, you don't get it as a rendering event arcs. But if you cast the arguments to a rendering event arc, you can actually get the time that this frame is happening on. And it's basically just a time span of some random time. So the first time, I actually check this is the first time it happens. I just grab whatever time is the first frame at, and I'm going to use that to figure out how far is the next frame. So here, just cancel out. And next time, I basically calculate, well, I'd like to have my duration to be, for instance, 1 second. So this value would be 1,000. And I calculate how far I am, and I can basically get, am I halfway through, am I a quarter way through, am I almost at the end? And then I basically just use that fraction to calculate basically the delta between the two plus the starting point, and then I just get the new position. And it's really that simple. You just keep moving the geometry. I would like to have this built into the API, and I'm pushing that and hoping we can do that. So you just have a single API call, but right now you just do this 60 times a second, and the thing moves. And then when we actually have the time that duration has exceeded where we want to go, we just snap it to the end geometry and then remember to unhook. And that's really what that is. But I didn't really like the way it looks. It kind of moves at it doesn't feel very natural, it does. So we have this thing called easings and basically have more of an acceleration and deceleration that makes a much more natural look to it. I have a little code in here, and WPF actually have this whole easing framework. It's called, I have it defined up here, it's called a quintic ease. There's a lot of different types of easings, and I'll get back to that in a second. But it basically kind of changes the value. So when you say you're halfway through, maybe it changes the value maybe only quarter way through. And if it's acceleration, and then it catches up at some point. So when you get to 1 all the way through, it actually has the similar value. So let me show you what that actually looks like. Close this one and build it. So now when I move, it does this acceleration and then it slows down again. I think that looks a lot better. And then I found this website that's called, I have a link to it here. I thought that was really cool. There's a website here called easings.net that shows all these kind of things. We're going to find the quintic ease. Where is it? I thought there was a quint. There it is. So I'm using this quint ease out, in, out. You can kind of see that little red thing when you hover on it. Whoop. Or you can do various. When you hover on it, it kind of shows the different things. And I was looking at this one. No, yeah, this one, I believe. Or was it this one? I like this little bouncy one. Of course, I couldn't help myself. So I found the implementation of that easing. I created my own custom version instead. So I'm just going to do this one. And this makes it a really fun app that you probably would never actually do in the real world. But it's just a little bouncing thing here. But that's kind of the essence of what an easing can do. It just changes kind of a little bit what that intermediate is. It creates some really cool effects. And so what this gets really useful is I wrote this geo event server sample. And so we have all these vehicles driving around. If you just update their location, you're not really sure, was this a new car? Or was it one that moved over there? But by adding animation to them, it actually gives you kind of a tracking of that it went from here and or it went out of the view and so on. So this one's actually tracking flights. So you'll start seeing these start popping in as they come from the geo event server. And you can kind of see them once in a while when they report an update. It does this little smooth animation. This works exactly this way. I wrote a little more efficient, so we had a lot of animations going on at the same time. It reuses the same event loop and has some queuing in there, and all this source code is up on GitHub as well. You've probably seen a few animations by now. There's actually quite a lot in here. It's still loading, but there's about 6,000 so far, and they're still coming in, and this is actually a really fun service. Unfortunately, this one is secure. The sample online uses some buses of LA, which is actually real time too. But I think this is a really cool sample, and so we shared this online. So we don't have a geo event server built into the API right now, but again, that sample shows you how to do it yourself. And it actually works cross-platform because it's just some .NET code that can be run on all these platforms, and I'll show that later. Yes. So if you do want to do cross-platform, you can't use the composition target event on Android and iOS. Again, the implementation online has a cross-platform implementation if you're interested in that. But these are the other classes I've used. Again, you just go on our demos repo on GitHub and find it. I was on an airplane this weekend, and I was tracking my own flight. It was kind of funny. That was totally worth the in-flight Wi-Fi to do that. So I can actually follow my own flight, see it, look out, and it actually did match quite well. That was kind of cool. I was actually surprised the Wi-Fi network on an airplane could keep up with all that data, but it actually did really well. So, all right. Trick number 2. This is the second demo of stuff that's not in the API that should be. Let me shut this one down. And I have there's a lot of secrets in our API. Geo events, like the whole streaming thing, it's on our backlog, same with animation, but right now these demos show how to do it. And another thing we get a lot of requests for is, how do I do a heat map? I have a lot of data, and I want to show a heat map. And a little known secret is there is already heat map in the runtime. There's just no API for it. We haven't gotten that far, but when you load a web map and it has a heat map renderer defined in it, it actually just works. So you can actually piggyback on that, because you can create a renderer from JSON, and that JSON spec is actually very well defined in the web map spec. So I've created this little simple sample with just a little text editor, and you enter some JSON in there, and you click the little apply render, and all that apply render does is it says my layer.render equals render.fromJSON on that string. That's all it does. There's no API that after you say, oh, this is a type renderer or a heat map renderer, and there's properties you can change. If you want to change them, you just do the from JSON again. But you can actually do this. So I can now, all this data here is kind of hard to make sense of. This shows graffiti incidents in San Francisco. But if I apply a renderer and just do that, it just parses the JSON. So I would show the code for this, but it can actually fit on one line on the slide. So I'll show that in a second. But it's really just render.fromJSON. It's pretty basic. So I actually get that information. And if I want to modify them a little bit, I want to maybe add that extra color step in between. Some cartographer is probably going to come after me now that it probably doesn't look cartographically correct, but you see we can go and change all these values on the fly and kind of get a different feel for it. Make them a little bigger, so you can actually tweak it to your data that way. So that's kind of a little bit of a secret little trick there's in there. And there's more of that. And we'll get APIs for this at some point. We're working on it. But if you don't have them yet, this can be quite useful. Another thing that's recently was added to the web map was this concept of visual variables, and my data is not loading. That is interesting. It's going to be a very sad demo if there's no data. Should be connected. That is odd. It's working earlier. But there's more JSON.
The heat map demo looks good if you apply the renderer while the features are loading.
That's it. But I want my features. Because there's actually more, so we have a normal class break render, but we have this system of visual variables that allows you to completely change the render and actually change the symbol based on other variables. There's data. It came. I was just being a little slow. So I can click one of these features. Let me see. I think my network is struggling right now. I hope I can identify. There we go. Clicked a little while ago. So I can basically, here's just the number of people between age 18 and 21. But I can actually apply a render that has this background fill symbol and a class break that's just a symbol marker symbol. Whoa, that was interesting. Wow, this is fun. That wasn't supposed to happen. But so let's try and apply this and actually see what happens. I'm not doing too well right now. Come on. I clicked back right when it came back. Let's hope the our cache friends are kicking in here. Maybe we can come back to it. But it's the same idea. There's these visual variables, and all this is actually documented in the web map spec, and you can actually parse these and use them. And we're working on getting actual proper APIs you can write code against. But for those who can't wait, unfortunately, when you apply the render, it figures out, oh, I need more attributes. It only downloads the attributes it needs, so it actually goes and fetches them again. There we go. But now we actually see dots on each one. I think it's kind of cool. And the size of the dots is actually use this age and make them between size 5 and 40 and all these colors. I can add more. Actually, I have a little snippet here I can copy. And I can do multiple. So what if I use the color also? I can change the color based on that field. I probably wouldn't be using the same attribute for both. But you can actually mix multiple attributes. So my fill symbol suddenly became My field system became a marker symbol instead, and I can change the outline of this. I can, let's see, I want to make this a little thicker. Too. Something is going on here. Oh, so the blue got a little wider. Really? Ouch. And simple thing, I'm really quick, actually. You can do the same with symbols. Symbols actually have this whole advanced sim spec, and that's actually not documented, but you can create these style X files like mil2525D, grab all these advanced symbols. I'm going to add a couple of points here, and I can actually apply this. It's a little more hard to see. There's a little symbol that says GOV here. This is actually letters. Let's see, find something fun. There's a lot of symbols in here. I don't know what half of them means. I like these weather symbols. Let's see. Bounded areas of weather. That was the only thing that was there. Cyberspace. I wonder what that is. But there's a gazillion things you can do with multicolor symbols, all sorts of funky lines you can do. And it's all JSON, and you can pretty quickly reverse engineer what all these things do. There's some colors in here, and you can actually do really advanced symbols. Some of the, before I use SAML or symbology, this might actually be your way out to do some more advanced symbology. All right, Mike?
Okay, thanks. Thanks, Morten. Okay, so continuing that theme, actually, let's take a look at labeling. Okay, so same application. What I've got on the left-hand side is the JSON definition or JSON representation of a label definition, and on the right-hand side is the map view, and it has the blue lines are a utility pipe network. So we do have labeling, a basic labeling API within the SDK right now, but it essentially just has label definitions from JSON. And then the documentation describes the properties that you need to set and how you set this up. But I just wanted to show an example in case people have missed that. So what we need to do first of all is add some text to label. So into the label expression info, I'm going to add an expression in here. And apply that to the map, and that will place the labels along the lines. One of the other things I wanted to highlight in here actually is that as we add more, as we improve the support for labeling, we're adding support for additional properties in here as well. So some of these things in here, like the deconfliction strategy, we've added some additional behaviors in there. We've added a new property, line connection, which handles how to place the labels at intersections. So useful on street networks and utility networks, for example, in order to either minimize the number of labels displayed or display unambiguous labels to label every part so there's no confusion. Multi-part behavior, and also then the repeat label property, and also the repeat label distance. So those are some of the new things that we've added support for, and you just specify those within JSON. If you're wondering where to see this, it's actually the labeling info within the web map specification. So I said we've got documentation on this. If you look at the guide documentation for the .NET SDK, there's a guide topic on labeling graphics and features within your map. And it links to the web map specification of the labeling info. So if we wanted to place more of those labels for the deconfliction strategy, if I just copy the dynamic property and paste into my application up here, so I'll replace static with dynamic and then apply that, and you can see it's placed a couple more labels. So what it's now doing, it's a more expensive operation, but it's trying a different variety of properties, placement options for each label, in terms of where it can place it on the view. The other thing to say in here actually is you've been hearing about arcade expressions this week. And in this expression, you can actually add an arcade expression. So if we take a look down here at this comment, what I want to do is I want to add that label based on one of the fields within my data. So if I just have this $ feature material, that's going to use the material field within the data set to label those. But actually I want to pull out more information than that. I might want to concatenate fields or make a more complicated label. So let's take a look at one of the other examples here. In fact, if I grab this, then we can see we're concatenating a couple of fields. If we paste that into the expression here, then it's now concatenating the material and also the diameter of the pipe as well, and adding a little inch symbol on there. But also, actually, that material field I know has a coded value domain set up in the geodatabase. So what I really want to do is label that based on the coded value domain. So this last example down here, we can see the expression is using one of the arcade functions to pull out the domain for that field. So if I just replace this expression, and apply that, we'll see it's now displaying, in the majority of those, a 6-inch or 8-inch cast iron pipe. So that's a quick demonstration of how to use arcade expressions within the API. There's excellent documentation both on labeling info in our guide documentation for the .NET SDK, but also the web map specification for that labeling info object. And then if you want to know more about arcade expressions, you can go to developers.arcgis.com/arcade, and there's even a little small playground in here where you can start testing out some of these expressions. And if you pick the labeling profile, then you can see things like, well, actually I could grab the current map scale and I could label I could add labels to the map based on the current map scale, or there's the example of labeling by the field name within the data set. Moving on, the next demo we've got is just about running Python scripts within the API. So again, you've been hearing about Python at the conference this week, and what I want to show is how to run a Python script within the ArcGIS Runtime SDK for .NET. So this is a WPF application that we're looking at here. I've got the world base map. What I want to do actually is browse to a file geodatabase, which is not directly supported by the API actually, but I'm going to use the runtime local server component that will allow me to browse for a file geodatabase, view the contents of that as a list, and then pick one of those items and display that on the map. So if we browse down into my SRTM dataset here, I can actually, if I pick this all types geodatabase, that's going to browse that geodatabase, and then it's going to list all of the items in there and give me a list their data type as well. But the one I'm really interested in actually is if I back up and go into that SRTM dataset, there's a dataset of SRTM mosaic here, and if I load that, that's now adding that to the view, and we'll render that within the map view. So let's take a very quick look at the Python script that does that. And I've written this custom Python script here. I'm just viewing it in Notepad. You could use other Python IDEs, obviously. I grab the workspace that I provide. That's essentially the input. I browsed for that file geodatabase folder. What I do is create an in-memory table, and then I iterate list all the feature classes in there and insert each item that's a feature class into that table. I do the same thing for mosaics, rasters, and raster catalogs, and then ultimately I just return that table back and then just translate that and display that in the UI at the end. I'm missing out an entire big piece here, which is the whole workflow for the fact that I have to run this Python script in ArcMap, create a geoprocessing package, give that to a local geoprocessing service using the local server component, and then I access that via the API. You can quickly see here that I've got a Python script that I can run within the ArcGIS Runtime SDK for .NET and provide access to some extent. It's really a great extensibility point for the SDK to provide additional access to data formats and run analysis, data manipulation, that kind of thing. Right, so that was the last of the demos. Or tips and tricks. Let's hand back to Morten.
Thank you. So I'm just going to quickly touch on a little bit of cross-platform. So we're going to have a session about Xamarin right after here, right? Mm-hmm. In here. That really dives into more of the cross-platform. But for those of you who don't really know it, I just want to show it real quick. So this is, I didn't have time to buy this app, so it gives me ads once in a while. There we go. So this is basically the exact same map you saw earlier, and these are runs on a phone. So the one on the left there is actually an iPhone 10 simulator running on this Mac. But you can actually, from Visual Studio, you can actually remote over to a Mac, and then it'll send back the picture back to the PC. So you can keep your Mac closed the way it should be, and you can stay on your Windows PC, which is amazing. So I don't actually have to, after you set it all up, you don't actually have to touch your Mac again. Makes me very happy. And I can even do touch on the simulator here. Mac can't do that because it doesn't really have touchscreen. But that's actually really cool. And the Android app is actually running a projector from Mac. I have it on the phone here, but the same thing. And you actually see you get great performance. I was even surprised. It actually performs excessively well. It's this processing over 200 messages a second, constantly parsing all these messages and updating all the rendering, animating, and so on. And it just works. It's quite amazing, actually. And it really didn't take me too long to get him running everywhere. And just want to show real quick what that looks like. So really, all the meat of this is in this top project right here. And you do see there's actually 4 projects. There's one for each platform as well. And all these platforms really are, you're going to have a platform-specific app in the end that actually launches it. But all they do is really just call into the page in the shared project. This is using Xamarin Forms. And then just launches that page. So if I go into my UWP app, for instance, you would see in here some normal main page, and it says launch that Xamarin Forms app. So this is just normal XAML app, but it's really just launching that other Xamarin. And from then on, it's all shared code. If you go into Android, it might look, for those who've worked with activities, again, it just launches that app. So there's a little bit of platform specific, but this is all auto-generated for you when you set up the project. All the meat is up in this common project up here. And this is where, here's my map page, my view models, here's all my stuff for doing all the talking to the server. This is all WebSockets, this is all in .NET code, so it can just be reused. Here's all my animation code. Actually, the animation code is heavily platform specific because I showed you there was all these different APIs for figuring out how to get the event for each. So they have to see if Android, I use this thing, if iOS, use this other thing. But the public surface of my little object model here is actually the same. So in a way, the code from when I was calling this class is kind of cross-platform. So I did all my specific platform-specific thing here. And this is actually something we're using that it's fairly new. It's called multi-targeting. This is not a shared product that some of you might have used before, where you put in a share and just reference the shared code again and again. This is actually a project in its own. And if you expand it, you'll actually see it knows about all these platforms. You can actually see Mono, UAP, all the platforms this project supports. I can keep drilling in and say, what's inside UWP? Well, there's some NuGet packages. There's the forms package. Oh, there's the UWP package, and there's the DLLs that are actually referenced in the end. Similar with, if I go on iOS, you'll see the iOS package. So it's actually slightly different. So and this actually builds into, this project builds a NuGet package that is then referenced by each of the other projects, and it picks up the right target. It's really cool. If you go into the project settings, you can actually, this is actually the entire project file. These new project files are very short. It just auto-includes everything. And up here, you'll see there's iOS, there's UWP, and there's Android that is targets. So that is multi-target. And we actually just put up a project template up on the marketplace if you ever want to set something like this up. So you can just go into Tools, Extension Updates, and you just search for the runtime.NET multi-targeting in the online store, and you get a set of new project templates that sets it up for you real cool. It's changed how I write my cross-platform code. I think it's really awesome. Yep.
All right, thanks, Morten. Right, essentially that finishes most of our demos today, or most of the session. We just want to take a quick look at the roadmap for the ArcGIS Runtime SDK for .NET, the roadmap for 2018, essentially. What we'll be looking at is a release coming up probably in the summer, focusing a lot on web GIS, so support for a lot of new 3D layer types and enhancing support for scene packages and mobile scene packages. Also, one of the other really exciting things we're looking at is support for .NET Standard. So now I'm going to hand back over to Morten, who will take us through that.
Thanks. How many here have heard about .NET Standard? What about portable class libraries? Right? So yeah, .NET Standard essentially replaces portable class library. It's more or less considered dead. And we heard you loud and clear. You want to have support for it, and we are going to add it in the next update. And we actually already have it internally, so I'd like to show you what that looks like. So here's the project I just showed you with the 4 target frameworks. So I'm just going to pick version 3, which is this new secret version. And I am going to go and take all this stuff here. I'm just going to remove it. Net Standard 2.0 is the new version I'm going to do. And this actually doesn't have to have all these workarounds to make multi-targeting work, so I can delete a bunch of this stuff. And I hit save, and look what happens over here in my dependencies. They're going to be a little yellow for a second as it's trying to figure out everything. But all these different targets actually disappeared. And what's going to happen now, I'm sure I can't expand. My Visual Studio just crashed. What's going to happen now is Visual Studio is going to crash. There we go. It's working. There we go. Now it's a .NET Standard library. And all this code I written is actually, before it was generating 3 DLLs and a single NuGet package with 3 DLLs, now it's creating a single DLL that can be referenced and run by all these 3 projects. So this is actually really cool. So, and that means that other .NET Standard libraries can also reference this library and then maybe build more stuff on it. So I can maybe take this animation library and the geo event stuff and split in 2 separate geo event packages, and then one can reference the other just fine. Having said that, let me just undo all these changes, because what happened to my cross-platform code? I lost it, as you can probably. You saw all the code I had for the stuff, the event loop. I can actually just add it instead. And that actually gives me the best of both worlds, because now that code I had in ifdef, it'll actually generate 4 assemblies now. It sounds like worse, but now even more assemblies. I just got rid of them all, and I just added one instead. But it's completely transparent to you. It creates a NuGet package, and it automatically picks the right DLL when it deploys the app. But when you're working with it, everything is .NET Standard. And this is called bait and switch. And we actually use the same trick under the covers, because our libraries have a lot of platform-specific code in them, but you don't see it. You don't see any of that. It's completely hidden away. I'm going to have to go back to version 3, or the build failed, but it's because I'm referencing 3.0, which is 2.1, which is not supported. There we go. That should work. So now you actually get this benefit of kind of best of both worlds. You can do platform-specific code, and you can still be a complete .NET Standard compliant API, which I think is really, really cool. It's restoring, it's working. It should build. But I think it's really powerful, and the whole multi-target actually brings you exceptionally close to .NET Standard. It actually doesn't, it almost feels like the same thing. There's not much difference left, actually. So I recommend, if you're really anxious to start using .NET Standard, take a look at the multi-targeting first. You're pretty much there with that. That's kind of that's where it's going. There is a couple of things on that I want to say. We are going to have to change the system requirements a little bit to support this. So is that on your slide?
Yeah.
Oh, is that coming later?
Yep.
Okay. I'll get back to that in a second. I thought it was on your slide.
So yeah, actually we're a couple of minutes over time. So very quickly, some resources. All the slides will be available to you afterwards. So these are just some links for you to reference afterwards. And then the thing that Morten wants to talk about is a change to our system requirements.
Right. So we're going to up the minimum requirements to what .NET Standard 2 requires. It's kind of enforced that way. So currently we require .NET Framework 4.5.2, which is shipped with Windows 7. 4.6.1 is shipped with Windows 10. And that's going to be min requirement. And what we found is pretty much everyone already has it installed on Windows 7, so we don't think that's a big issue. But if it is, we'd like to hear it. UWP is the same thing. We're actually going to require creators fall update when this ships, because that's the minimum version. That might be, for those UWP, that is a little quicker push than we first anticipated, but last I heard 85% already have that version, so it's coming out really quick. Xamarin, there's no changes. They're basically already compliant. And we're going to make one breaking change. We're going to change the type of color to be the cross-platform color type. And so if you're using System, Windows, Media color on WPF, or Windows Foundation color in UWP, it will now be System Drawing color everywhere. So that will be the only break and change that actually introduced in the code. So you might have to change, if you're setting in code, setting the color on a render or something like that. That will have to be changed. So that's one break. We weren't too happy about it, but there's not really a way around it, because we need the cross-platform color type. And up until then, it was all different color types. So just Xamarin actually already used that one, so they, again, don't get a break and change, so they're actually happy there. So just a few heads up on that. That will change. But it actually, if you're doing cross-platform code, you had a bunch of if-defs for that, and it was a nice thing. We just deleted all that in our code. It was really, really nice. So clean up our code.
And that's it. So thank you very much for listening to the session. We're just a couple of minutes over time, so unfortunately we don't have any time for questions.
We can do a few
live. No, we can jump off stage and we'll take questions at the back.
Sorry about that.
But yes, thank you very much for listening, and Morten and I will be available.